with the first presentation. I'm honored to present Boris Pedraza, uh, who is a recently graduated engineer, systems engineer, and representing Universidad Privada Boliviana in Bolivia. And his research aims to improve the accessibility for remote laboratories for all kinds of users across the world. The title of the presentation is Enhancing Accessibility for Real-Time Remote Laboratories, a web-based solution with automated validation and access control. So, please, Boris, the floor is yours. Yes, now we can also see your presentation very well. Thank you.
Okay, can you hear me well?
Yes.
Okay, amazing. Oh, sorry. Okay, so welcome, hello everyone, I'm Boris Pedraza. Transforming a traditional laboratory into a remote laboratory is not an easy task because you need to take care of multiple factors, for example, providing a reliable connectivity, securing data privacy, and also integrating the equipment of a traditional laboratory that most of the time is not, it was not originally designed to work with remote laboratories. This is why we present a solution that is a web-based solution that aims to be secure, that enhance the accessibility for all kind of users, and that also comes coupled with multiple features, multiple and automated features. Oh, sorry. Okay, so I will briefly describe the presentation offline. First, we will talk about remote laboratories. I will give some background, what are the main challenges and other stuff. We also will see, I also will present the proposed solution that is called a BridgeServer. I will present the overview of the solution, what technologies we use it, what are their main features, and how it works overall. I also present a real use case where we had the opportunity to collaborate with a university, with external university, to implement our solution. And we will finish I will finish the presentation with some conclusion and acknowledgements. Okay, so remote laboratories. I think wait a minute. Okay. Background. Remote laboratories have emerged as a great solution in the current education paradigm that empowers students to use in real time a laboratory from any geographical location. These solutions have multiple benefits like cost savings, accessibility, and flexibility, among others. But there is a main challenge, is that multiple laboratories are configured to use a well-defined architecture to work. For example, let's say SCADA systems that are systems to gather data that are running on Windows operating system, for example, and can only run in that operating system because the infrastructure is designed to do that. Also, this implies obviously some drawbacks because people or students using, for example, Linux and Mac cannot interact with the laboratory. Those laboratories also use a control software most of the time to manage the laboratory that is within an internal network. This control software also most of the time is proprietary and closed. So the main challenge is that how we make external students to utilize the laboratory from inside a university, to utilize the infrastructure. So the question is how we grant access to students. We make some research, and we discovered that most of the laboratories that have this situation are using the two most common approaches. The first one is the use of remote desktop solution, like well-known applications such as TeamViewer and AnyDesk. So in order the student can connect remotely to the host machine that is running the control software. Another solution is the use of a client control software. This means that the students explicitly installs a control software inside their machine in order to interact with the laboratory. But obviously these approaches have some shortcomings. For example, they provide selective accessibility, meaning that only the students that fulfill all the requirements, in other words, have the Windows operating system, for example, installed, and have all the required software in their computers, can access and can interact with the laboratory. This obviously creates a barrier for all the students that doesn't fulfill those requirements. There is also manual supervision. Manual supervision is mandatory. This means that if you grant access to the control software to external students, you need to take care of what the student is doing, and there is no automated way to do that. You need to really be there and control and supervise what the student is doing with the laboratory. And also, there is no automated time control. This means that the system cannot generally control for how long a student is using the laboratory. So, BridgeServer is a solution to overcome all of these shortcomings. It's a tiny web server that creates a remote session environment, so the students can connect remotely and use the host computer and therefore the control software. It acts as a gateway. It means that it sits in the middle of the user trying to use the laboratory and all the infrastructure that is, for example, perhaps inside an internal network that manages the laboratory. So now I will present some features of this proposed solution. The first one is that it's web-based. In other words, it serves a web page that creates a remote desktop session, so the students can directly interact with the control software from their web browsers. This eliminates the barrier of having to use a specific operating system or the installation of, for example, a third-party software. It's also integrated with a booking system. This booking system was previously developed by us, and it works as follows. An instructor creates the laboratory and creates time slot sessions that can be reserved. So the bridge server will only consider the students that previously booked a session. This way we enhance security. Also, we have automated time control. This means that the bridge server provides a way to close a session once the allocated time of the booked session was elapsed. And importantly, there is no password sharing. For example, solution like AnyDesk needs you to share a password to the person or to the student that you want to connect to your host computer. BridgeServer handle all the password internally, so the connection is made in a transparent manner. Okay, core features. Additional features. The BridgeServer also presents some additional features to improve the overall functionality of the remote laboratory. For example, it allows remote file access that from a specific path location in order to download laboratory files, for example, or data files. And also supports live video streaming in order so the student can visualize the laboratory in real time. Okay, now I will present some technologies that we used in order to achieve the functionality of this solution. First, to create the remote session environment, we use a well-known system called VNC, that is a desktop sharing system. And we use NoVNC, that is an open source project that creates a VNC client using JavaScript and HTML. We use TypeVNC, that is a VNC server, and we installed this in the host machine where we want to access. We use Node.js as our core server that have all the functionality, and also is the one in charge to serve the web page. We use Nginx in order to use it as a reverse proxy and to forward client requests to specific services and overall improve functionality. And finally, we use Docker in order to containerize all the solution and enable an efficient deployment. Okay, architecture and workflow. Now I will present how the system works and the steps needed in order to achieve the desired functionality. Okay, so the first step is that the student or the user needs to log in and book a session for the laboratory in the booking system. The booking system will generate a link pointing to the bridge server, and this link contains some metadata. The metadata in step 3 is parsed by the bridge server, and in step 4 is the bridge server is interacting with the booking system to validate the reservation. Once the validation is successful, it serves the main web page in step 5 that have all the core functionality and also the VNC client. After that, the bridge server connects the VNC client to the VNC server in the isolated machine that also have the control software. As you can see, okay, as you can see, all the university infrastructure of the laboratory is inside an internal network. So the only point of access is the bridge server. And well, once as I mentioned it, the password is handled internally. So the student once the student interact with the web page and with the remote desktop session, it connects in a transparent manner with the machine. And now the students can control the control software and interact with the real laboratory. This is the main workflow overall. So now I will present to you a simple demo of how the web page looks and how it works. Okay. Okay, so let me take you. So here we have the main web page. We have some features in the top, like the timer that indicates the student how much time it has left. We have at the right the show stream button that toggles the video streaming window. In the bottom, I don't know if you can see, we have a download files button, so the student can download the files from a specific path location. And also in the center is the main container where the remote desktop session will start. So, okay, as you can see, we have the timer, and the student can see the stream, the real life stream. It's in a window so that you can drag, for example, and you can resize in order to work with this alongside with using the host computer control software. Here we are already connected to the VNC session. So we are right now using a host computer directly from our web browsers. We accommodate the windows from to other side. We can now download the files. As you can see, it downloads in a .zip format. And finally, the most important thing that is interacting with the software controlling the laboratory. Yeah, you can access, you can do all your stuff, and once the allocated time has elapsed, your session will be closed automatically. This is the demo. Okay. Now I will present a real use case of our solution. We had the opportunity to improve and slightly adapt our solution because we collaborated with the University of Sao Paulo, USP from Brazil. We use the BridgeServer to enhance the USP's refrigeration and air conditioning system remote laboratory. But here the question is, why do we need to do that? Why do we need to use the BridgeServer? It's because its prior implementation have multiple flaws. For example, the control software that they use in order to be installed, needs to be running in a Windows operating system, but not only that, it also needs to run directly via the Edge browser. So it was OS and browser dependent. And also there is no session and time control automation in the use of this laboratory. So with all this in mind, I will present the architecture and the new architecture and workflow to make this laboratory work. As you can see, most of the architecture remains the same. The interaction with the booking system, how the booking system creates a link and how the validation is being made is still the same. The server of the web page and the interaction with the VNC client with the VNC server is also the same. So the main change is inside the third-party control client that needs to be installed. It needs to connect to an external server that is not inside the university implementing the solution that is in this case is us because we implemented and we tested in our servers. So yeah, the third-party control client needs to connect to the control server in order to be installed, and also once it's initialized, then it also connects to the control server, and then it can interact with the laboratory. So the students connect to the web page via the bridge server, and the connection with the control software is directly embedded to the control server, and then it can interact with the real laboratory. Okay, so as I mentioned it in the previous step, in here we have a Windows machine. So the student once the student book a session and connect to the solution, it can have control as in from it can have all full control of the Windows machine, as you can see, as you can saw in the demo. So how do we, this is a security measurements, because what if the student wants to make some malicious practices? For example, I don't know, downloaded a viruses or making a data leak. So, okay, the students have full control over the Windows computer without supervision. This is a problem. To fix this, we made the following. First, we automated the installation and installation of the control software. We created a script made in C# to, to automatically install the software without the interaction of the user. And we made the software to initialize at a startup. This way the user doesn't need to interact directly with anything of those steps. Also, we restrict the Windows user so it can only interact with the control software. This means that we restricted the account so it cannot open other applications such as browsers or external application, and we disable multiple Windows functionalities like the access of settings or the access to the control panel. This way we have a secure machine and the student can only use the computer to interact with the control software of the laboratory. And here I present the solution showcase. As you can see, we also have the main features like the timer, the live stream button, and the download files. And this is the control software running in the Windows machine. That is the software of the USP's laboratory. Okay, so our solution BridgeServer brings to the table multiple features. It brings accessibility, adaptability, and enhanced functionality for the implementation of remote laboratories across the world. Our solution overall improves how remote laboratories are being accessed and uses a user-friendly web page. Our solution also has multiple features that improve the interaction that the student have with the laboratory. Those features include automated actions like time control and access, and also other additional features as I mentioned it, like the live video streaming and the possibility to download laboratory files, for example. Our solution was tested within an international remote laboratory network that is within the Explore Energy Digital Academy, the EEDA, and also is currently being used in multiple countries, like in the use case Brazil, but also Bolivia, Cuba, and Sri Lanka. And finally, and most important, our solution is completely open source, so it's open to anyone who wants to test it and implement it in their remote laboratory. Before finishing, I would like to make some acknowledgements. I would like to thank Universidad Privada Boliviana, that is the Universidad Privada Boliviana team. Also, this project was partially funded by the Erasmus Plus EU BBC Digital. And I would like to send a special thanks to Professor Alberto Hernandez Neto from University of Sao Paulo, Brazil, that helped us to test the BridgeServer real use case. Thank you.
Thank you very much, Boris, for this really interesting presentation. We have time for a few questions. Any questions from you who are online or you who are in the room? No questions, at least so far. You said I have one question. You said in the end that this is completely, open and you can use it. How do you do if you would like to use it? Are you contacting you, or is it an open source somewhere where you can just find it, or?
Yep. At the end of the slide, I present a URL, a link to the GitHub repository. That is where all the open source code is. So you can also that repository have a README file that is like a guide file that you can follow the instruction in that file, and you can make your remote laboratory work with our solution. Or you can also contact me.
Okay, great.
Okay.
Any other questions? No? Then thank you very much, boys.
Thank you.